Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 147. Maximize subarray sum after removing all occurrences of one element. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Honestly, this one is, how long did I take? I took half an hour, but I actually just did the math wrong on this one with respect to the complexity. If you watched the live portion of it, I actually got the idea that it was going to be the segment tree for this problem very early. And the segment tree problem, it's one of those things where honestly, it's at least half knowledge. I don't know. Not gonna lie, during the contest, the reason why it took so long is because I did the math wrong. And what I mean by that is that I thought with the segment tree it would be n squared still. But I'm wrong, right? So that's the short answer, right? Is that I was wrong. And that's why it took me a long time. I actually should not have taken this long in retrospect. And some of it is because I already had the Cadene's algorithm with segment tree. I know how to do it. I think I may or may not. There was a Leetcode problem from maybe a year ago, and I give a lot of props to two members of my Discord channel, Just Gia and Lenny, for kind of teaching me this. I didn't know how to do this the last time. Something similar came up. I forget what the problem was. I mean, I'm sure if someone reminded me, I would know how to do it. It's just I don't remember the problem. But the idea, because the reason why I don't remember the problem is because I remember the idea. And the idea here with segment tree, and I actually even wrote the wrong code, but today like I said, I just did the math wrong initially. That's why it took me a while, but I had the idea. But the idea here is that, okay, so I'm not going to go that deeply in the segment tree or the segment tree portion of the segment tree because this is a kind of a hard problem. I don't even think most people need to know segment tree for interviews. I've never heard of a segment tree for an interview except for some people say, I mean, I feel like people have used segment tree for interviews, but it doesn't mean that segment tree is required for interviews, right? Maybe that's not true for India and online assessment type OAs, but I don't know. That's my opinion anyway. And honestly, for most people, if you're doing it for interviews, you probably do better just practicing anything else because we could be better at dynamic programming. That probably is more helpful, right? In any case, so I'm not going to go over segment tree. The idea behind segment tree is that let's just say the idea is that you can, answer these queries, right? You can do a range query of some sort in O of log n. And there are some high constants to this, by the way. But yeah, so range query, and you can do an update in also O of n, right? Or log n, sorry. O n would be too slow, obviously. And there's some other nuances. There are different types of segment trees and so forth. But the idea here is that, it's not quite precise. But the idea is that, okay, you have some nodes, right? And this represents from 1 to n. And this represents, roughly speaking, I mean, it doesn't have to be a power of 2, so it's not whatever. But yeah, it's going to be n over 2, and then n over 2. Oh, this is 0, actually. Well, no, this is 2n. So you can think about it kind of this way, and you could kind of construct it whatever, right? N to the 4, right? And then n to the 4th to n to the n over 2, right? The 0 is for a node. I don't know. And then so forth, right? Dot. You can imagine. And the idea here is that, if you do something magical, an example is just like a max number, right? Getting a range max query. If you do an update, then you just kind of go through this tree, update it, and then update the result afterwards. So the updates are pretty straightforward. For range queries, you just do a combination of different things, right? So for example, if you want from I don't know, 5 to 10, right? Then, well, I mean, we're using n, so it's a little bit confusing. But basically, you just kind of combine different nodes. For example, it may be that the answer is from like, let's just say this node to this node. Let's say you want to go from n to over 4 to n, then you just combine the answer for these two nodes, right? I mean, you could kind of combine them in any ways, but that, because this all subdivides until that, this all subdivides until you have one cell. So this will be going from 1, and this will be 2, and then dot 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 all the way up. So then here you can just kind of combine a lot of pieces. So, and there is going to be at most log n pieces to get the answer, right? I know I'm going really fast. This is how I understand it, and it's not, nothing is memorized. This is all just like learned and kind of memorized, and or not memorized, but just like learned, and these are core ideas that you can do to kind of reproduce it, right? Okay, so let's say now, and you want to learn more and more detailed, obviously, there are videos on the internet, or even just regular articles that are not videos. Definitely check that out. So, okay, so to get the max number, you just get a max of all these nodes, right? So that's pretty straightforward in idea. So, okay, yeah. Okay, so the first thing is, actually it doesn't really use Kadane's algorithm, but the idea here for this problem, and it's kind of hard if you haven't seen it before, is that, okay, so now you have, let's just say, let's just focus on 3 nodes, right? The parent node and then the two children, right? The idea is that there are only 4 different things you have to keep track of, right? So, okay, so given one node, and this node, let me change the colors actually. Look at one node, this node represents a range, right? A range of numbers, or a range of indexes in a thing. And of course, this propagates down to things, right? But we'll ignore that, because let's just say that we already got what we need. Okay, so how do we figure out the max within this subarray, right? Well, the max within this subarray, and keeping in mind that this subarray now, maybe I should have done this one, whatever. This subarray now consists of answers from 2 smaller subarrays, right? I mean, I'm drawing them, whatever, but Then what can and then it's just case analysis in a way. Because then now, what is the best answer for this subarray? Well, the best answer for this subarray is just going to be either, there are 4 scenarios, right? One is that the answer is totally in the left side, right? So on the left side, let's just say this is the max. I'm going to color it in to pretend that's the max. Then it's just all the way on the left. So best is the left side max, right? Because so you just kind of propagate that up. The second possible case is that it's on the right side. So then now we just have right side, right? And then, yeah. And then the next possible case is, the combination of them, right? So what does that mean to be a combination of them? That means that, again, I'm redrawing this real quick using another color, is that it is the suffix of the left plus the suffix prefix on the right, right? So that means that you have left suffix plus right prefix, right? And you could calculate this pretty, straightforward in a way, right? Because it's just, and then there's one more case, right? Maybe that's it. No, maybe that's fine, right? So that's basically the idea of doing these merges, right? Is that you have left, the answer is left, to right, and then the prefix and right prefix. And that's basically it. So then for this node, then now you can keep track of the best using these 3 things. Maybe there's a 4th one I forget, but if I remember, then we'll figure it out, right? And then the idea here is, though, of course, is that for this thing, we have to propagate up. So this is the idea for best, which is now going to be the new whatever this component is, right? But then now we have to take out the left suffix and the right suffix, and that is just, yeah. So then, without the loss of generality, we can just look at the left suffix because it's just mirror on the right side, right? Then the left suffix, I'm just trying to find a different color to use that is still readable. All right, whatever, this is good. Okay, so then the left suffix is just equal to the previous. So now we're trying to figure out, okay, how do we figure out the left suffix for this, right? Like, how do we figure out the best left suffix? Yeah, like, if this is going to be the next, the parent's left suffix, how do we calculate that, right? Well, this is just equal to the children's or the right size suffix, right? Unless it extends all the way through, because if this is the entire thing, then now you want to add the left prefix or left suffix to it, right? Plus maybe left suffix, right? All right, terrible handwriting, but you get the idea. So that's basically it. And then now inside this cell or this node, which is this node, by the way, then now you have the same thing, right? You have the best, which is the best within that segment. You have the left, suffix, and you also calculate the right prefix, or maybe just prefix and suffix. Maybe the left right thing is kind of confusing, right? But basically, you just given. Okay, can you raise them? Yeah, you just contain the best suffix and prefix, and then let the parent use it however they want, right? So okay. So then the only other thing that you have to keep track of is that this is best, as in best. Yeah, I guess that's fine, right? I feel like I'm forgetting one thing, honestly. Oh. Yeah, I guess, yeah, and then the idea is that you just keep track of a total of the sum within the subarray. And the reason why you could keep total is that you could answer this maybe. Oh, how did that happen? The reason why you want to keep track of total is that so that you could keep track of this maybe statement, right? Because the maybe is if the right suffix is equal to total, then you add the left suffix, right? That's basically it. And if you keep track of these four things, you're able to kind of do this propagation up, and also when you update, you can update these and then propagate it back up. And that's really the idea behind this problem with segment tree. Yeah, find a window. Okay, and that's it. I mean, once you realize that, then yeah, I'm not gonna lie. For this one, I had pre-written code because I was I think I actually practiced this on a I don't know if I could find it actually, because I written this before. Hang on. Contains. Nope. Max subarray. Okay. Leetcode contains algorithm. I should have had this ready. My apologies. Okay. Because when I first came out, when I first realized this idea, when Lenny and Gia was telling me about it, I actually went back and, yeah, actually this divide and conquer thing, but yeah, yeah, I did go back and implement this using different code, but so I actually did go back and implement this using segment tree, right? So pretty straightforward, honestly. Maybe I should have even used this code, really. But oh no, there's no update in this one. That's why, because I didn't think. Well, I just didn't think about using it with updates for some reason. But yeah, but I did go back to solve a medium problem, and that's why it was so slow with segment tree. So just to be clear, like, you know, we've done something like this before. Actually, that wasn't that long ago. That was only half a year ago. I thought it was longer. But yeah, I think that was when Lenny and Gio was telling me about different, because there was a contest problem that dealt with a similar idea, but not this idea. I forget what it was though. But where you have to combine the nodes in an interesting way. And as a result, that's basically what I have. I'm not gonna lie, a lot of this is templated because I guess I've rewritten it somewhere. With the contained is just total sum, prefix sum, suffix sum, and the max sum, right? Things that we talked about. And yeah, and these are kind of just segment tree stuff. Like I said, I'm not going over it in detail because these are just segment tree things. And then the interesting thing is just in the merge. Everything is basic, and the merge, where do I have the merge? Oh, here it is. And yeah, and you have the left side and the right side. And yeah, the total sum is just summing it. Pretty straightforward. Prefix is yeah. Prefix is either the left's prefix or the total sum of the left plus the prefix of the right. And the reason why you can write it this way is because if the only way this is equal to like the only way that this is bigger than, oh sorry, the other way around, that this is equal to this is if you have the entire array. Otherwise your thing will have negative items in it, and as a result, that's not your biggest array, right? So that's basically the idea. So you can kind of write it this way for prefix and suffix. You can also write if statement, I suppose, so it's not a big deal. But yeah, and then the max sum is just, well, it's either the left max sum, the right max sum, or what we talked about, merging it in the middle. And that's pretty much it. That's the only thing that's different from a quote unquote a normal segment tree. The query is the same. You just go, you go up, down, and then you merge the results. And then update also is the same. You just update the tree nodes to go that way. Yeah. Same as the thing. So when I said that, and I got a wrong answer because I forgot how. I don't know how to do the case where all the numbers are negative, or at least non-zero. So I just kind of added a thing for it instead of fixing my segment tree because I had like 3 minutes left, or less than 3 minutes left. So yeah, you can probably fix segment tree to do it so that it's non. Yeah, I mean, I think it's just more if statements to kind of build a case where you have to have at least one element, because it just makes it easier. But yeah, otherwise this is yeah, for you. Otherwise I just keep track of all for every x I put it, or keep track of, for each number we keep track of all the indexes, and that's it. Here first, this is the initial thing of just getting it without removing any number. Though I guess that's only the case if it's all positive, because otherwise you can always remove at least one number to get a little bit better. But anyway, we already have it done here, right? So it's fine. Otherwise, then here, we only want to remove negative numbers. It doesn't matter. It just makes it a little bit faster because you would never remove a positive number. And then now for each index, you update it. I think the key observation that I also made for this, there are two things, right? One is that you could set it to 0. If you set it to 0, that is the same thing as removing it. I think that's the key part that took me a little bit of time to realize, to connect with the segment tree. And then, of course, we reset it afterwards. But in between, we just query for the best for the entire thing. and that's it. Yeah. So the way that I did the math wrong because I thought it would be n squared because, yeah, I don't know why I thought it that way, honestly. But I think it's because I was thinking about the updates and I thought that maybe I need lazy propagation with updates and so forth. But no, because you can actually do lazy updates and I think it'll be much faster because you're not merging all the time. But you don't need to as a result. Yeah, maybe I should have done it with lazy. Maybe I'll just ask ChatGPT actually to make it lazy. But yeah, that's pretty much it. And yeah, the reason why is because for each, even though there are 2 for loops and looks funky, and that's why I got confused for a bit, is that for each number, for each index and the number, you're only going to update it once, or I guess twice here. So that's why it is going to be n log n, because in total, every number just gets updated twice. I think it's an up-south. So how long does this take, right? I mean, I think this part is not that interesting. So, this particular part is straightforward. The idea is that you just have to convert it to 0 and then just do the query over the entire thing again. This ended up taking 11 seconds, which is actually feels a little sketch. That was more than 24 minutes ago, right? Oh no, this is the other one. Oh no, oh yeah, no, 7 seconds. Okay, still not great, a little sketch, but not too bad. So yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, you could watch me solve it live during the contest next. It is kind of okay. Let's look. We have 40 minutes left. Let's at least look at Q4. Okay, because I think we got it, but I don't know. Just Leetcode setting. Okay. Following most ones, choose any integer x such that nums remain non maximum Subarray sum across all. Oh yeah, I might as well YOLO. And what did I change? Oh, I added the cache courier. Is that it? Okay, I don't know. At most ones. All possible subarrays. So basically, we move all numbers once and then okay. I guess n is big. Yeah. That's kind of awkward, actually. Like, why would it not return? Remove 1. Oh no, it's max. Okay, so. So obviously n squared is going to be too slow. I don't know if I have any ideas on this one immediately. I think this one's a little bit tractable, but I hate Leetcode. I mean, we spent about like, I don't know. We'll talk about it later, but at least 15 minutes on just like Leetcode things, right? Java. I should have done Java. I don't know why I did C++. I wanted to change it up a little bit today, but that's just dumb. Okay. I mean, I don't know. should have known better, I suppose. Okay. I mean, I guess I could have done it bottoms up. I think maybe that's the other way of doing it, but okay. I'll solve later, Larry. Okay. Q4. I don't know that I know how to do it, to be honest, but I just wasted so much time because of Leetcode. Well, you always want to remove a negative number, but it isn't always the biggest number, right? I guess that doesn't really generalize it enough. But okay, so we can merge all the positive numbers, right? Okay. We can greedily merge all the positive numbers because we'll never remove them. So then now you have a lot of consecutive negative numbers. And you get to remove one of them. But the thing is, you can combine them still. How do you sap all the numbers away? Because then it's just variable length, it's not the entire thing, right? And it's too big to do anything reasonable, other than binary search maybe. The n unique different number. It's always going to prefix something. No, you don't want the entire thing. Can you do it with a segment tree? No, I don't think so. Well, for each number you remove it and I don't know. I don't think segment tree is the way to do it, but I mean, this is such. I mean, Q2 was all me, but Q3 I feel like it's full. And Q4 I just don't know how to do. This is probably not just greedy of a big number. Because you can have a lot of big small numbers, right? You have to do a loop on the numbers, right? Probably. There's really no deep here about it. Okay, so I mean, there's some optimizations, but I still feel like it's n squared as a result. We only have half an hour, so. If I think about it as connected components, how can it be? Just a depth first search. That's gonna be n squared, right? And even if you think about it in terms of that, it changes the answer even if the components are not. Well, you could recalculate the answer. That part's not an issue. Do you want the maximum number of components? I guess so. Because in a greedy way, that is always ideal. Oh, but then you have this decision thing. I guess that doesn't really make sense. My rank, I put 15 minutes is ridiculous. I don't know that I know how to do this one, honestly, even when I'm awake. Non-empty. So this is the one without the right. Yay, we got one input right at least. No, yeah, that decision doesn't make sense with components. Okay. It feels very segment tree, or like maybe divide and conquer anyway, which is part of the segment tree thing. But you're still modifying like on removal. So okay, so removing, but it's also setting an element to 0. Okay, maybe that's another way of thinking about it. But I mean, that's fine. I'm gonna do some waiting, but I mean, this is. I feel like other than, yeah. Okay, So it's setting it to 0. How would that change it? N square is definitely too slow. I don't know what I'm doing. There's still 18 minutes left. I don't think I'm getting it. But who would even have any ideas? Yeah, I don't know how to do it without it being... Oh, maybe it is. Maybe I could do it with segment tree. Okay, I think this is a segment tree then. Because then you amortize it over... Oh, I see. Oh, that's great. Let me... I've written this now. Let me find if I can find one. That's it. Yeah, okay. Because you amortize all the log n operations. Okay. Oh, that is... Okay, yeah, okay. I'm trying to find my thing. Okay, so this is the thing, the segment tree that I had. This is how to use it. I don't know about this part, but okay. I need to rewrite this at some point. Yeah, I just copied up ChatGPT in the past. Okay. I think this is the part that I care about. I guess we can play around with this, right? Yeah, at least we can do it for these. I always hate the query things. That's not great, actually. I mean, before I need to have, I know how to do it, but why is it 4? We don't do any updates. So then why is it wrong? Oh, because of the negative, I think. No, where do you get 4 from? Oh, actually, am I just wrong? This should be 4, right? This is 4. So actually, my best is wrong. Wait, yeah, why is that wrong? That is terrible, actually. I think negative is... So this is negative infinity, maybe. But... Three. Maybe something like that. That's pretty embarrassing, actually, that I got contains wrong. Okay, so let's say we have this then, right? Okay, then now we want to change the update such that we want to change the update with lazy propagation. So actually this is wrong, but that's fine. What we want is, okay. Oh, we don't need this. Right, and then now we want to say okay. We have a lazy update. I don't know that I'm going to finish in time, but it is what it is. Okay, so then now x for index and indexes of x. Want to update sec3 update to n-1, I think. Index to 0. and then we want to say this thing actually, and then we update it back to X, right? And then that's it. Did I miss this one? Oh, I don't know. What, this is crazy. Seven, 9, okay, that's good. Oh, I didn't do the thing where, yeah, okay, I have to do this first. Okay, 710. Okay, it may not be fast enough, but at least it should be right. It'll probably time out, but I want to at least get something in. Let me convert it to another language. Why not? Yeah, it's gonna time out, but I think this is right though, the idea. Because if you do lazy correctly, this should be right. Oh. Oh, well. That's why did it take so long to say that? But we want the merge. What are my 4 values again? I always forget. I forget my notation. Totals. Oh, totals. Oh, there it is. Max sum, right? Max sum is max. Right? How do I fix this? How do I fix this? Well, okay, yeah. If all the numbers are... Oh, I actually also want to change this to only if negative. Oh. But we also want the max sum. If only I have slightly more time. We could fix it anyway. I don't know. So new. YOLO try. I mean, it might time out, but at least we'll you know, feel good about it, I suppose. Okay. I mean, it's ridiculous, but it's fun. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest, these problems, this description, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.